Hello, today we are learning the CO17. I can find prime factors of a number. So in order to find the prime factors, we need to look at what is a prime number. A prime number is a whole number. Oh goodness, that's a spelling mistake there. A prime number. Oh my goodness. So it's definitely not breather. So let's look at our book and see what Mrs. Gambino wanted that word to be. Oh goodness, it happens to the best of us, doesn't it?
It's greater.
Oh my God. A prime number greater than 1. A prime number greater, so change that on your paper. So that's what happens when autocorrect fixes a word for you. Prime whole number greater than 1, whose only whole number factors are 1 and itself. So if we look at 5, its factors are 1 and 5. There's no other factors to it, so it has to be a prime number. A composite number is a whole number greater than 1 that is not prime. So an example would be 6. We have 1 and 6, but we also have 2 and 3 as factors. So prime numbers, only itself and 1 are the factors that multiply into it. Composite numbers have other numbers you can multiply together. Prime factorization, expressing a whole number as a product of prime numbers. So we have 54, and we're going to break down all of our factors, and we're going to see how it becomes 2 times 3 to the third power. So if we look at that factor tree, we use the factor tree to help us with that prime factorization. So the factor tree is a diagram that can be used to write the prime factorization of a number. So we have 54. We can divide 54 into 6 times 9, because we know those are 2 factor buddies that equal 54. So we can break down 6 and 9 even farther. We want to go all the way down to our prime numbers. 6 can be 2 and 3. 9 can be 3 and 3. So we want to get to expressing it as the product of prime numbers. So there's 1, 2 here. Times, I see 1, 2, 3 3s. So that's why we put it 3 to the third power. So if we multiply 2 times 3 times 3 times 3, we would get 54. So that's how we use that prime factorization. So in order to really work on using those prime factors, we need to have a good understanding of what our prime numbers are. So let's make a list of our prime numbers. We're going to circle numbers that are prime, where its only factors are itself and 1. You cannot simplify it, divide it down any farther. So we should all be working on our page together with me. Is 2 a prime number? Yeah, because the only factors of 2 are 1 times 2. Is 3 a prime number? Yes. The only factors of 3 are 1 and 3. We can't break 3 down any farther. We can't say, well, 3, I can get there by multiplying these 2 numbers together to equal 3. It's only 1 times 3. What about 4? No, because we can do 2 times 2 equals 4. So it is not prime. What about 5? Yes. The only way we can get to 5 is 1 times 5. What about 6? No, we can do 2 times 3. We can know that any even number after the 2 is not going to be prime. It is a composite number. How do we know that? Brielle?
Because
Any even number you can divide by 2. So we know any even number after 2 is not a prime number. So we're just going to go through and we're going to cross off all of our even numbers. Because we know they cannot be prime. So now that makes it a lot easier. We're just going to work with our odd numbers. 7, is it prime?
No.
What can you multiply together to get to 7, Nick?
Nothing.
So it's prime.
Oh, yeah.
So 1 times 7 is the only way we can get to 7. What about 9? Can we multiply something together to get to 9 besides 9?
Oh, yeah.
Penelope?
3.
3 times 3, so that is not prime. What about 11? 11 is prime. 13 is prime. The only way we can get to it is multiplying itself by 1. What about 15?
No.
No. What can always go into a number that ends in a 5?
5.
5. So any number that ends in a 5, we can cross off because we know that's a multiple of 5. So let's make our life a little bit easier and cross off any number that ends in a 5. All right, we just narrowed down our list to work on for primes. 17, just 1 times 17. 19 is just 1 times 19. What about 21? Penelope? Or Brielle? 3 times 7, so it is not prime. 23 is a prime. What about 27? 3 times 9 is 27, so it's not a prime. 29 is a prime. 31 is a prime. 33. 3 times 11 is 33. 37 is prime. 3 times 13 is 39. 41 is a prime. 43 is a prime. 47 is a prime. 49 is 7 times 7. 51. 3 can go into 51. 3 times 17. 53 is prime. 57, 3 can go into it. 3 times 19. 59 is prime. 61 is prime. 63, 9 times 7. 67 is prime.
What was 49?
69, 7 times 7. 69 can be 3 times 23. 71 is prime. 73 is prime. 77 is 7 times 11. 79 is prime. 81 is 9 times 9. 83 is prime. 87 is 3 times 29. No, 3, yeah.
3 times 29.
Yeah. Ooh, I missed that.
3 times 29 is
What?
3 times 29.
I did it over on the side too.
There's 280s.
What?
Never mind. What?
Okay, 91
Actually, yeah.
is prime. 93 is prime.
Yeah.
97 is prime. 99 is 9 times 11. So for numbers below 100, those are our list of prime numbers. You're going to want to know this for when we work on our prime factors. Writing factors of a number. A class of 36 students is on a field trip at the aquarium. The teacher wants to break the class into equal groups of the same size. Find all the possible group sizes by writing all the factors of 36. So think about our factors of 36. What numbers do we multiply together to get to 36? Well,
6 times 6.
6 and 6. So I'm just going to write the 6 one time. When we write factors, we only write each number once. Well, W.
12 and 3.
What else are factors of 36? Tristan?
36 and 1.
1 and 36. What else? Tristan?
9 and 4.
Nick?
2.
And? 2 times what would get us 36? 13. 2 times 13 would be 36. So these are all our factors of 36. So if the teacher wants to break the class into groups of the same size, these are the number of groups she could have. If she breaks them into 6 groups, there will be 6 kids in each group. If she breaks them into 12 groups, each group will have 3 kids in it. Depends on how many chaperones she has to go with each group of kids. Maybe she's got a ton of chaperones, so she's going to break them into 12 groups with 3 kids. Maybe she doesn't have a lot of chaperones, and she'll break them into 3 groups of 12 kids. Yes.
30 times 2 is 26. It would be 18 times.
You're right. Thank you. Sure it is. So, when you're looking to find out possible group sizes, think about your factors. Look at those factor buddies. Which numbers go together? Identifying prime and composite numbers. That's where this list is going to really come in handy. 47. Is it a prime?
Yes.
We circled it. Yes, it is. 81. Is it a prime? No, it's crossed off. 34. Is it a prime?
No.
34. It's an even number. So even without looking, I look at it and say, oh, it's an even number. It cannot be prime. I can always divide a 2 out. Now, using our factor trees. So we have 30. We need to do a factor tree of 30. So we have, I'm going to do it over to the side so I have room to work so you can see it. So I'm going to look at that 30. 30 is an even number. My brain always jumps to, oh, it's an even number, I can divide a 2 out. So I always jump to breaking up my numbers by 2. So that'd be 2 and 15. Do you have to go with the 2 and 15? No, you could do 6 and 5. You could do 10 and 3. Do what works for you. It works for me whenever I see an even number to break it up by my 2's. So 2 cannot be broken down anymore. That is a prime number. 15 is not prime, so I need to break that down. 2 is going to stay because if you can't break it down anymore, it's prime. 15 can be broken down to a 3 and a 5. 3 is prime, 5 is prime. So the prime factorization of this would be 2 times 3 times 5.
So it would be 6 times 5.
No, prime numbers. 6 is not prime. You're only writing the primes. We're breaking it all the way down to the smallest numbers we can. So we would say 2 times 3 times 5. That is the prime factorization. It's got prime in the name,
Yeah,
so keep it prime. Let's look at our next one. 48. Again, my brain jumps to those 2's. 2 times 24 equals 48. 2 stays here. 24 can be broken into 2 times 12. So then I keep my 2's. And I can break that 12 into 2 times 6. Keep my 2's. 6 can be broken into 2 and 3. Now I'm down to all of my primes. So it's going to look like this. 2 times 2 times 2 times 2 times 3. We have a lot of repeat numbers here. That's when we can use our exponents. So it would be 2 to the what?
What's the mode of this?
2 to the power of 4, because there are 1, 2, 3, 4 2's here. So we would write that as 2 to the 4th times our 3.
What's the mode in this? It's obvious.
It is not a data set. It is prime factorization. So you want to break it down to all of your prime numbers, and if you have the same number repeated, you can write it with an exponent. One last one before it's time to go. We have 44. I like my 2's. 2 times 22 equals 44. Keep my 2. 22 is 2 times 11. We have all of our prime numbers. We can't break them down anymore. So we have 2 times 2 times 11. We have 2 2's here, so that's 2 squared times 11 is our answer. We are going to continue with this lesson tomorrow, so we fully understand prime factorization, so we do not have homework tonight.